right? So this is so handout 3. So reference dependent example. And there's this Avero individual, and his utility is given by phi C1 minus R1 for right now at the moment, and where C1 is money, right? C1 is money, and R1 is the reference point for money. Right. V, so V is a function in which it's equal to x if x is bigger than 0 and equals to 2x if x is more than 0, and get the equal sign is up there. And as I have already drawn before, this is simply a loss aversion function in the gain domain. In the gain domain, you have something like this. In the loss domain, you have 2 times the slope. Okay, so that's what we have. And then we're going to normalize initial amount of wealth to 0. So he has no money to begin with. And then okay, so in initial, no, initial has only, okay, that's just INITIAO. Okay, so initially no money. So C1 is 0. So now part A. Avero has just agreed to take part in an experiment, and he was told by the organizers that he might receive $10 for his participation. And suppose Avero can choose whether to incorporate the $10 into his reference point, calculate his utility with reference point of 0 and a reference point of 10 if he received $10 for his participation, and then calculate his utility with a reference point of 0 and a reference point of 10 if he received nothing. What reference point use high utility? The first question is a bit weird. It says that, well, what if he can pick his reference point? And essentially the question that is asking, given that he can pick his reference point, what should he pick? Is it better to expect getting money, or is it better to not expect getting money? Which one would make him happier? Instead of saying he can pick his own reference point, maybe you can think of it as saying that if you have these 2 individuals, one is very sophisticated, like he understands, he knows that if he goes to experiment, he's going to get some money, and another one is kind of like myopic, or he's kind of naive. He doesn't know that if you participate in an experiment, you're going to get money. Who is going to be happier? I think that's a very philosophical question. Is it better to be sophisticated, or is it better to be naive? And you can see that you can kind of see this as the question asking that in this model. So let's go into do that. So we have 4 cases to consider. So this is part A. You have 4 cases to consider. And so the first case. So the first case is he gets money and he's naive. So so Avero didn't expect to get money, but he did get something. So this is the case where someone naive managed to get money. What happens? So everything works according to our utility model. And phi 10 minus 0 is just 10, because 10 is bigger than 0, right? So he's actually happy, right? He's happy. He gained something that he didn't expect. Happy. What if he's sophisticated? He gets money, but that's something he already expects. So utility function is phi 10 minus 10, that's 0. Next, C. What if he's naive and he got nothing? Well, that's okay, because he didn't expect anything to begin with. And finally, what if he is sophisticated? He kind of understands that experiments gives you money, except this one doesn't. So he gets nothing, but he expects something. Now that's going to be worse, because now he's being let down, and that's negative. That's in the negative region, and that's going to be negative 20, right? So what do we get? In this case, you can see that the reference point of 0 generates higher utility. Right? If you think about it, it makes a lot of sense. Expect nothing, you'll be pleasantly surprised. If your expectation is high, you could only be disappointed. That sounds like something that like something you should teach people. Like this is like a life teaching or something, right? So while it might sound a bit weird that people can pick their expectations, there are two reasons why that this is not as weird as it is. One is, I think people do try to manage their expectations. Whenever an exam is coming up, right? There's always a classmate who tells everyone else that, oh, I'm gonna do really poorly. I haven't studied at all, and then they come up doing very well. What's that? Well, that's in some sense expectation management, right? They can only be pleasantly surprised because they have like this guy has told everyone that he's not going to do well. He can only fare better, right? Whereas if you're someone who say that you're going to do very well and then you didn't, that would be pretty poor. So that's one reason. Another reason is, we also, from an economic theory perspective, we do also want a theory of how the reference point is generated. How do people actually set that reference point? Now, if you are talking about economic theory, everything is done to maximize utility, which means the reference point should also be picked, or reference point should also be settled in a way that maximizes utility in equilibrium. That's economic theory, maximizing things in equilibrium. So part of this reason is, one way you can think about this is this is like a survival of the fittest. If some people are naturally born with high expectation and some people are naturally born with low expectation, who would survive in the long run, right? It seems like people with low expectation would survive in the long run, because those with high expectation would be so sad. They're not going to have like, I don't know. When people are sad, maybe they die early. So another way of looking at it is, in equilibrium, it seems like low expectation, which should be what happens, because that gives higher utility to people. Okay, so now next question, we're going to make it more complicated now. Instead of just having money, Avero is going to have the choice of mugs and pens. So okay, so what we're gonna have now is, so now with mucks and pens. So now the utility is going to be V C1 minus R1 plus V 4 times C2. 4 times, so there's a typo in the handout. It's 4 times C2, not C3. So 4 is 4 times C2 minus 4 times R2 plus V 4 times C3 minus 4 times R3. And I think this is muck. And this is pen. Okay. All right. And obviously, R2 and R3 would be their reference point, respectively. Essentially, what this utility function say is a pen should worth $4 and a muck should worth $4. That's kind of the idea. So he's gonna initially start off with nothing, right? He's gonna initially start off with nothing. Why am I keep writing initially with 2 I's in the front? Initially, C1 equals to C2 equals to C3 equals to 0. So he has nothing. And now he comes to the experiment, and it turns out that he received $8 show up fee that he does not incorporate into the reference point. Okay, now puppy. So C1 equals to 8 and R1 is 0. He did not expect to receive the money. Now he's given a muck, and he does incorporate this into his reference point. All right, so C2 equals to 1, and he incorporates that into his reference point. So R2 is also 1. And he's no pen. There's no pen. All right, C3 is 0. So he also is not expecting any pen. Okay. Calculate his selling price by writing down his reference point, solving for the price P that makes him indifferent between keeping in muck and not receiving nothing, and giving up his muck and getting some money. All right. So we're now looking for a selling price. Okay. And I'm going to call that PS, right? In some sense, this is basically a modification from the experiment I mentioned. But instead of exchanging for a candy bar, we're just asking what would be the price he's willing to sell the muck for. He has this muck, and we assume that he already incorporates that into his reference point. How much money do you have to give him in order for him to sell the muck? Okay, so as in any case, when you calculate these kind of choices, binary choices, you look at what's the utility if he does nothing, and what's the utility if he sells. If he does nothing, well, he keeps everything, right? He gets to keep everything he has right now, but he's not going to get additional money. That would be he has $8 that he has not incorporate into his reference point. He has a muck that he does incorporate into his reference point, and then he has no pen. So. Right, so once again, this is money, this is muck, right, this is pen. He is gaining in money, so that's 8. He's not losing or gaining in pen because in mucks because he already expect the muck. So if he does, and he's certainly not getting anything from the non-existent pen. So in the end, his utility is going to be 8. Now, what if he actually sell the pen for some money? Sorry, sell the muck for some money. Right. So now we're going to sell the muck for some money. So if he sells the muck, he's gonna get some more. He's gonna get some additional money, 8 plus PS, which he doesn't expect anyway. He's gonna lose the muck that he does expect, and once again, the pen doesn't really serve any purpose here. But this is losing the muck. And gaining more money. Right. Let's see what he gets. So his utility is going to be, he's earning even more money, so he's further into the gain region. He's losing a muck, and remember, losing in this case, you have to multiply by 2. So this is actually going to be negative. This is going to be 2 times negative 4. And once again, it doesn't. The pen doesn't do anything right now. So in the end, he is getting how much? 8 minus 8 plus PS. So okay. So that's just PS, which means for him to sell, you must make him at least as good, as better off as if he does nothing, right? That's the idea. If you want him to sell, you must pay him at least the amount of money that makes him as better off as if he does nothing, which means that has to be $8. So that's the minimum price. Okay, you have to at least give a pharaoh $8 for him to be willing to sell his muck, because you have to compensate for the fact that he is losing a muck. So you have to pay him enough money. You can pay him more than 8, but no less. This is part B. Part C asks, what about the buying price if he doesn't have a muck to begin with? So once again, C1 equals to 8, R1 is 0, C2 is 0. Okay, R2 is also 0, and C3 is 0, R3 is 0. Okay, he's not given a muck. How much would he be willing to pay for the muck? We call that PB. Once again, utility if a pharaoh does nothing, that's going to be $8, not expected. No muck, no pen, which would be 8 plus 0 plus 0 equals to 8. utility if Avero buys a muck. This time around, it's going to be V8 minus P B minus 0. He's spending some money that he did not expect to spend, plus V 1 muck that he did not expect to have, plus no pen. So that's 8 minus PB plus 4 plus 0, which is 4 minus 12 minus PB. What does that mean? To make him, so that means that the maximum he's willing to pay should not make him worse off than if he does nothing. And so 12 minus PB equals to 8, and that should be 4. That means he's willing to pay 4. So Avero is willing to pay at most $4. Notice that this is half of what the selling price is. The selling price is 8, but the buying price is 4. Once again, this is the idea that loss feels a lot more painful than a forego gain. In part C, he's spending money that he did not expect to have. He's spending money he did not expect to have, so that makes him more willing to spend money. But that means he's spending money that he does not have, and he is getting a muck that he does not expect. So he's not losing anything. That allows for a lower price. In part B, he's selling a muck that he does expect to have. And that makes it expensive because he doesn't like losing things. Part D. Argue briefly that Avero's buying and selling price for pens are the same as for mucks. Well, this would be easy because the utility function is identical. So part D is actually quite easy. Mucks and pens enter Avero's utility in identical ways. So we should expect them to be the same. Okay, so we have 2 more parts, and then we're going to take a break. Part E. So now for the rest of the question, for part E and F, suppose Avero has 2 options in the experiment: to buy a muck for $7 or to buy a pen for $6. Okay, so the price muck equals to 7, and price pen equals to $6. Suppose Avero arrives at the experiment with a reference point of having 1 muck and 1 pen. Okay, so he comes in, this is part E, and we were told that he expects to get a muck and a pen. Right, so R2 equals to R3 equals to 1. That's His reference point in money is still 0, and he still received the $8. So C1 still equals to 8, and R1 is 0. So the key the key idea here is that he expects the muck and the pen, but he actually wouldn't be given any for free. Okay. So C2 equals C3 equals 0. He expects to have them, but he wouldn't be given any. So what would he do? So the question is, buy muck. Would he buy muck only? Would he let's see. Okay. Would he buy muck only, buy pen only, or buy both? So this is really like kind of free question in one. What would he do? Buy muck only, buy pen only, or buy both? Utility, if he not, so let's start with the utility. If Avero does nothing. This is the case where he's going to be disappointed because he came in expecting a pen and a muck, but he wouldn't be given anything. So if fee, we're going to have fee $8, not expected. No muck, even though he expect one, and no pen, even though he expect one. So no expected muck. No expected pen, so he's like kind of losing out. So the price is going to be 7 and 6. If he does nothing, then he obviously not buying anything right now. So he's going to get 8 from unexpected money. Negative, so 2 times -4 from not having the muck he expect. And 2 times -4 from not having the pen he expect. And his utility is going to be -8, right? So now buy muck only. If he buys the muck only at $7 each, then he's going to spend 8 minus 7. So he's spending some of his unexpected money. He's going to get a muck, which he does expect to have to begin with, and still not getting a pen. So that's 1 plus. That's 1 plus 0 plus 2 times -4 equals -7, right? That's slightly better off. That's slightly better off. What about buying a pen only? So pen is $6. So spending some money, not getting a muck, even though expected one, getting a pen and expecting one, and that's going to be 2 plus 2 times -4 plus 0. That's -6. That's even better because the pen is cheaper. And finally, what about buying both? Wouldn't that satisfy all his wants? So buying both is expensive. He has to spend $7 on the mug and $6 on the pen. And you can, as you notice, that actually makes him in the red. He does get the pen, the mug he expect, and he does get the pen he expect. So that's, unfortunately, he's losing money. He's spending more money than he expected. So that's 8 minus 13, right? That's negative 5, and because this is in the lose region, you have to multiply by 2. He gets the mug that he expects. He gets the pen that he expects, but he's spending so much money that he is very deep in the red. Negative 10. So what can we tell from this exercise? What we can see is that doing nothing is negative 8. So buying a pen, buying a mug, or buying a pen would improve the situation. At least he's not completely disappointed. However, buying both would make him worse because he's spending money that he did not expect to spend. So Alvaro would be willing to buy only a mug or buy only a pen. Yeah. Okay, so I see. So you're saying like why are we? So let's see. So here in this question, I'm using expectation as what his reference point is, right? He's expecting to get a mark in the experiment. So in some sense, I guess I'm using it in the English sense, not in the statistical sense. He's thinking that he's going to get a mark. He's thinking that he's going to get a pen. It turns out that he's not going to get either. What is he going to do? Yeah, you can say that too. The reference point, you can say that he wants a mark, he wants a pen, but he's not getting either. Right. So then one is also ambiguous because whenever we talk about utility and preference, right? We say people always want more. So that's why one is also not a very good term to use. So the most accurate would be saying he. So that's why I'm saying he's. So I use he expect to get a pen, but you can say like if you want a most neutral way, it would be his reference point is he is going to have a pen, and then he doesn't. What is he going to do? Right. However, so we're not really going to talk about the mathematics, but in a more advanced model, the reference point is actually an expectation in the statistical sense. Given that I don't know what's going to happen, how do I form my reference point? Well, it's going to be an expectation. I think there's a 50% chance I'm going to get a mark. I'm going to think that there's a 50% chance I'm not going to get a mark. Then my reference point is an expectation. But that's for a more advanced course because the mathematics gets a lot more complicated, as you can expect. So here, so he's either going to buy a mug or a pen because, well, in that case, he's not losing money. He doesn't feel losing money. Because that only requires him to forego money that he gained unexpectedly, right? Because he is only spending the $8 that he didn't expect to get. But if you ask him if he buy both, then he's going to spend money from his own pocket that he didn't expect to spend. Buying both would require him to lose money that he didn't expect, which is very painful. Right? So that's the idea. And finally, part F. Now suppose Avero can choose whether to enter the above experiment with a reference point of getting the mug or a reference point of getting the pen, knowing the prices in advance. Which one would he choose? So, is expecting a pen, so is expecting a mug better than expecting a pen, or vice versa, right? So once again, you can kind of see this as kind of a philosophical question. Is it better for someone to expect something expensive, or is it better for him to expect something that is cheap? Which one would actually make someone better off, given that he has the same amount of money? Okay. All right. Now this let's see. So let me make sure that getting a mug or versus not getting a pen. So what we need to do is we have two cases. One is, so let me actually call this case 1. Expect a mug. So that means R1 is still, so that means R2 is 1, right? You expect a mug. R1 and R3 is 0. The second case would be expect a pen, which would be R3 is 1. Okay. So, and then once again, we have to go through all cases. This is why the math actually gets quite tedious, because it's easy, but it's a lot of work. So you have does nothing. And now we can start doing it quite quickly, right? So you have fee, you have $8, spend $7 buying a mug, plus getting a mug that is expected, plus not getting a pen that is not expected. So this gives, if you calculate very quickly, that's just 1. Right. Oh no, sorry. Already. Oh, this is purchased. All right, sorry. Okay, so I'm just gonna erase and say this is buy mug, and if does nothing is V8 minus 0 plus not having a mug that is expected, that is, and then not getting a pen that is not expected anyway. So that's going to be 0. You can also calculate what happens if he buy a pen or he buy both, right? Needless to say, they're going to be even worse. You can also do that, all right? But I'm not going to do that right here. You can try doing that, but it doesn't actually going to affect anything because those are worse options. Okay, so you can calculate those. They are even worse. Number 2, expect a pen. What if he expect a pen? That means R3 is 1, R1 equals R2 equals 0. So buy pen, he's spending $6. He's not getting a mug that he's not expected to get. He's getting a pen that he is expected to get, and that would be 2. Does nothing in this case is going to be just very quickly writing everything. It's going to be 0 again. Okay. All right. Once again, you could calculate the buying a mug and buying both in these cases, and once again, they're going to be worse. The key, what the question is asking is whether it's better off expecting a mug and buying it versus expecting a pen and buying it. And the answer is it's better off expecting a pen and buying it because simply the pen is cheaper. Why? Now, the direct answer is that basically Avero is going to do what he expects because not fulfilling your expectation, not fulfilling what you think is going to happen is painful. So he's going to buy the pen. He's going to buy whatever he expects. He's doing so to avoid the sense of loss. Expecting a cheaper item means spending less money. Now, why is this important? This is important because when you have a theory that people do what they expect, you could have some crazy equilibrium where they do crazy things just because they expect them, right? This is kind of a self-fulfilling prophecy. You expect something to happen, you do it. So if that could make for some crazy things. I expect that I'm going to spend all my money, so I spend all my money. That's not that comforting. What we have though is that it does give high utility to expect something that's cheaper. That means that if reference points are picked to maximize utility, the individual will expect something that truly maximizes his utility, right? So if he expect to buy a mug, if he expect to buy a mug, he's going to buy a mug. If he expect to buy a pen, he's going to buy a pen. So it's self-fulfilling. what is he going to do? If we believe reference point should also be picked to maximize utility, then he's going to do the right thing. He's going to expect himself buying the cheaper item. That gives him higher utility in the end. More generally speaking, when facing two options, one is crazy, one actually makes sense. People should not expect themselves to do the crazy thing, right? They should expect themselves to do the right thing. So that's what this is. Choose in a model, if we want a model of how people form expectation, they should form the expectation to maximize their utility in the end, right? So in this particular example, it means that they should expect themselves buying the cheaper item because that means spending less money. In other contexts, it would mean that they would always they would always expect themselves to do the right thing. Okay, right. So we're gonna take a break here now. We're gonna come back in 10 minutes, and then we go back to talk about what evidence there are that suggests to us that loss aversion can explain the equity risk premium.